Good morning, student. I've already supplied the notes for this physiology of vision. So let's start. The physiology of vision is a complex phenomenon which is still poorly understood. The main mechanism involved in physiology of vision are there are three things that are basically. For physiology, three things is very much important. First, the initiation of vision. The another name of is phototransduction. What is that? A function of the photoreceptors, mainly rods and cones. We have already read the anatomy of retina, the second layer, layers of rods and cones. Second one, the processing and transmission of visual sensation. A function of image processing cells of retina and visual path. So this is the in-between process. So initiation of vision, then the process of the vision, then transmission is happening. The third one, once almost the process has completed, then the perception of the total thing, that is called visual perception. So a function of visual cortex or brain actually, related areas or cerebral cortex. So this is the basically three things happening in the physiology of vision. So coming to the first one, phototransduction. The rods and cones serve as a sensory nerve ending for visual sensation. Yes, the first rods and cones, only the receptor who receive the lights, definitely they are the first nerve endings. Light fall on the retina cause the photochemical changes in which the turns trigger in a cascade of biochemical reaction that results in the generation of electrical changes. So what is happening over there? Once the light comes to the retina, these the layer of rods, they receive that one, and there is a change is happening over there. What is that? The photochemical changes is happening, which are part of the biochemical reaction in the layers of rods and cones, and which produces or generate the electrical changes. So photochemical changes occurring in the rods and cones are essentially similar, but changes in rod pigment, basically rhodopsin, that is the rod pigment named as rhodopsin or visual purple sometimes they call, have been studied in more in details, because that is very important. So this whole phenomena of conversion of light energy into the nerve impulse is known as phototransduction. So what happened? So when light falls on the retina, that light received by the rods and cones, the layers of rods and cones, and there's a change is happening. What? Chemical and biochemical changes or reaction is happening over there, and the production is the electrochemical signals in producing over there, because the nerves only can carry that one. Light cannot be transmitted through the nerve, so that's why that changes all things happening over there. So we say that the phenomena, whole phenomena, this total phenomena of conversion light energy into nerve impulses, once the formation of the electrical changes, so that is become a nerve impulse. So that is known as phototransductions. So photochemical changes, which is most important part of the phototransduction. So what is that? So photochemical changes include the rhodopsin bleaching. Rhodopsin is what? The pigment, or what I said, the pigment of the rod, or rod pigment you can say. Rhodopsin refers the visual pigment present in the rod and the receptor for night or scotopic vision. So rods and cones are there. We know the receptor. So rods is responsible. Remember that rods is responsible for night vision. That is called photopic vision. And cones are responsible for photopic vision or day vision. With maximum absorption of spectrum around 500 nanometer. Rhodopsin consists of colorless protein called opsin, coupled with a carotenoid called retinine, that is vitamin A, aldehyde, or 11-cis retinol, sometimes they call. So Rhodopsin basically what is that? It's a protein organ named opsin, which mingle or couple join together with the carotenoid or retinol, or that is another name is vitamin aldehyde. Thereof 11-cysteine. They join together and form the rhodopsin. Light falling on the rods convert to 11-cis-retinal component of the rhodopsin into all transretinal through the various stages. I'm going to discuss that on next slide. All the stages from the transformation of the 11-cis-retinal to the all transretinal. The all transretinal so formed is soon separated from the opsin, and this process separation is called photodecomposition, and the reduction is said to be the bleached by the action of light. So what is happening over here? I just explain over here better. This is the reduction. You can see this is reduction. So once the light energy falls on that, so first is first the division is happening over there. Is a bath reduction. Then again lumi reduction. Then it's transferred to the meta reduction 1 and meta reduction. Then it's become a all transretinal. When all transretinal means isomerase is there, then it's converted to the 11-cis retinal. Or they come another pathway is there where the all transretinal, the vitamin A, that aldehyde, also mixed with the isomerase can produce the 11-cis retinal. So this is the whole process, and once the 11-cis retinal, the opsin is goes out from there, and then again reduction is produced. So this is the whole process is actually is happening in the photochemical pathway. Then rhodopsin regeneration. So once the 11-cis retinal is regenerated from the all trans retinal, so what happened? From the all trans retinal, 11-cis retinal regenerated due to the isomerase. From there, rhodopsin is regenerated. How? The option should be go out. So what is the story? All 11-cis regenerated from the all trans retinal separated from the option, and vitamin A supplied from the blood. So 11-cis retinal regenerated from the why? Just segregating the option. অপশনটা বেরিয়ে যাচ্ছে এখান থেকে all trans retinal থেকে যে অপশনটা বেরিয়ে যাচ্ছে then 11-cis retinal is going to produce. And who's helping? Helping the vitamin A, that is retinal. 11-cis retinal then unites with the opsin in the rod outer segment to the form of rhodopsin. Then again they mixed with the option and then produce rhodopsin. That's the common process afterwards. That is the here. So here from there again opsin binds and produce the rhodopsin. Whole process is called rhodopsin regeneration. Thus, the bleaching of the rhodopsin occurs under the influence of the light. Obviously, everything is happening due to light. Well, the regeneration process is independent of light, processing them equally well, light and darkness. So all the process is happening, the photochemical changes, everything is light sensitive. But here you see, there is no light is required. So that whether dark or light, both the processes same on. Coming to the visual cycle, in retina, living animals under the constant light stimulation, a steady state of exit under the rate at which the photochemical are bleached in equal rate which they are regenerated. What just now is what I said, that rhodopsin is bleaching and again regenerated. So what happened? Here they are bleaching and they goes again they go to the rhodopsin. So producing and bleaching, both things are there. So this is cycle only. So the equilibrium between the photodecomposition and regeneration of visual pigment referred to as a visual cycle, like this. See, rhodopsin, light energy, then excitation of the nerve, all transretinal, option বেরিয়ে যাচ্ছে, this goes out. So this is retinal isomerase, then 11-cis retinal, again opsin binds together, then rhodopsin. So whole it is cycle and is maintain the equilibrium. So very perfectly they done. Electrical changes, the activated adoption following the exposure of light triggers a cascade of complex biochemical reaction which ultimately result in the generation of the receptor potential in the photoreceptors. In this way, the light energy is converted into electrical energy which further processed and transmitted to the visual path. What is it? This is the most important. So rhodopsin, what is that doing? All the chemical, biomechanicals, all change, biochemical changes is happening over the ultimate goal is what? To change that uh, photo energy to the electrical energy. So light energy, photo means light energy. So photo energy or light energy is converted to the electrical energy. Then why is needed electrical energy? Because that can be transferred through the nerve, that optic nerve, and then is reached to the visual pathway to brain. That can go. I show the picture here. You can see. So once the production is in the retina, everything is here. So there has to go to the brain now. So how? So for the optic nerve, then this is called optic chiasma. Then there's so many. We'll read it when we go to the visual pathway. That I wrote and reach to the visual pathway of the brain. Now, let's see the receptors, the processing and the transmission of the visual impulses. The receptor potential generated for the photoreceptor is transmitted electronic conduction, that is direct flow of the electric current, not by action potential, to other cells by the retina like horizontal cells, amacrine cells, ganglion cells, we read already, so that they transmitted. However, the ganglion cell transmit the visual signals by means of action potential to the neuron large, of the lateral genicular body and by later on the primary visual cortex. The phenomenon of processing visual impulses is very complicated. Now it is clear that the visual image is deciphered and analyzed in both the serial and the parallel fusion. So what is happening here? So once the production is done, so they go through this optic nerve, then go to the optic chiasma, then lateral genicular body, then optic radiation, then the visual cortex. So this is something very much important because that is transmission of the visual impulses. So there are two processes are there by transporting these visual signals to the brain. One is the serial processing and the parallel processing. So two ways they can be. Serial processing what? The successive cells in the visual pathway that stretching from the photoreceptors to the cell and lateral genicular body are involved in the increasingly complex analysis image. This is called the sequential or serial processing of the visual information. So what is that? So the blue color one. So they directly goes to the brain through this pathway. So this is the serial processing. The parallel processing, two kinds of cells can distinguish in the visual pathway stretching from the ganglion cell. Retina include the lateral genicular body, straight cortex, and extracortex. So parallel pathway, what is that? In parallel pathway, they are starting from the retina here only, but they go in a different way. Why? Two cells basically. What are these two cells? The large cells, that is magno or M cells, and the small cells, that is parvo P cells. They are striking difference between the sensitivity of the P and cell stimulus the features. So what they do? They do by the color contrast. M cell they don't have any activity, but P cells they have. Luminous contrast, yes, they both have, but higher and lower. Spatial frequency, both have, but M cell lower, P cell higher. Temporal frequency, they have higher, these are lower. So these two are controlling also the flow of this sensitivity to the brain. Now coming to the visual pathway. So it is here. You can see clearly over this picture. M and P. So M cells, P cells are more, you can see, than the M. M is lesser. So the visual pathway is now being considered to need two frames. One made for the large cells called magnocellular pathway. Another one is a small cell called parvocellular pathway. So this so M for magnocellular pathway, this 1 and 2, and P for the parvocellular pathway, the 3, 4, 5, 6. This can be compared to lane of a rod, and the M pathway and P pathway are involved in the parallel processing of the image and analyze different features of it. So the function of it, they help in the processing of image and different features of the image, they help it. So that's all. I'll come into the second one, the visual perception, in the next class. Okay, thank you.